All right, so Unit 8, Day 5 notes. We are now on to the last section of Unit 8. This is not an easy section. Of course, like I said earlier, it's a ladder. Every single time that you learn a new skill or a new objective, it starts to build on one another. And in this case, it's at the top for the unit 8. So we are going to do our best to get through everything. We're definitely going to get through everything. And if you have any questions, please don't hesitate to email me. Or of course, make an appointment to come to an office hours. I'm here for you. I want to help you as much as I can, and we will do our best to get through all of this together. This one is not easy. There's a problem on here that is very, very long, a lot of different intricate steps, and we'll work through it together, okay? All right, so first and foremost, it starts off kind of crazy and kind of ending off where we left off last notes for unit 8 to day 4. This is kind of what you were doing last time, but it's very, very much so different. Okay, so in this one, like last time, we had the radicals on both sides. We do have a radical, we have a number on the outside. So, but we're going to handle it in the same type of way. It's just not going to be as easy to handle. So when you square that, of course, that just becomes, when you square root, it just goes away. But in this case, the whole thing is not under square root. So what you have to do is take 10 minus the square root of u, and then multiply it by 10 minus the square root of u. Okay, on this side, it will just cancel each other out, and it just becomes u minus 20. So that's what we like to see. But in this case, we don't like to see it, but it doesn't mean we can't do it. All right, we're going to FOIL it. So we're going to have 10 times 10, and 10 times 10 is 100. So 100 here. 10 times negative square root of u becomes negative 10 square root of u. Here, negative square root of u times 10 is negative 10 square root of u. And then remember, when you have two of the same square roots, square root of u and square root of u, it just becomes u on the outside, but they're both negative. Negative times a negative positive, so it's going to be plus u. Okay, this again just stays the same. We're going to kind of follow this down a little bit. All right, so now we have 100, and we're going to combine these two middle terms. Okay, they are like terms, negative 10 and negative 10 is negative 20. So negative 20, and then the square root of u plus u equals u minus 20. Now, when you get to this step, when you have a square root, what you're trying to do is get the square root by itself again. I know it looks like you're like, what am I doing all of this for? What you're trying to do is get the square root by itself so you can square it and get rid of it, okay? So our ultimate goal is u equals blah, blah, blah. All right, and in this one, our ultimate goal is y equals blah, blah, blah. So we're going to get the square root by itself. So let's subtract u, and you remember you can only subtract u from u because it's you have to have like terms. And then we're going to get rid of the 100. I can do that on the same situation. And again, I can only subtract it from the 20. So I'm going to cancel out both sides here. I'm going to bring down negative 20 square root of u. So I got rid of both of those numbers. Equals, this looks like it cancels out. U and negative u, yes. Negative 20 and negative 10 become negative 120. Okay. And then I'm going to divide by negative 20. So this is starting to look a little better. So square root of u equals what's negative 120. Negative 120 divided by negative 20 is 6. So we have 6 there. So a lot of things were happening here, and then it came out to be 6. Let's square it because we want u by itself, and we know the square root and square cancel each other out. U is going to be equal to 6 times 6, which is 36. Okay, so our answer there is 36. Yes, it seems like a lot, and it is a lot, but eventually it came out to be that nice answer. Okay. All All right, let's move down to this one. Same common situation, but yet not so much so. Let me show you how. This one, if you're squaring this side, you have to square this side because we're getting rid of the radical. This becomes w squared equals, guess what happens when you square a radical? If you square a square root, it just goes away. So this just becomes 8w minus 7. So it's not as crazy as this one up here, but we do have a squared value here. When you're having squared value, you want everything, instead of getting everything away from that squared value, you want everything on the same side as the square value. So let me show you. Let's subtract 8w, add 7. Subtract 8w, add 7. So what happens here is it becomes w squared minus 8w plus 1 equals 0. So when you have a squared value, you want to try to get everything on the same side. You want to have it make equal to 0 so that you can kind of factor it. Because you're going to have to solve, in this case, because you have a w squared, you should know you have 2 answers for the most part, okay? So now that we have everything equal to 0, when you have a squared value for the most part, that's what you're going to get. You're going to have everything equal to 0. Now we can factor it. Same or different, we have same, because the last number is positive, meaning that it's going to be either both negatives or both pluses in this case, okay? In this case, it's going to be both. Oh, this is not, this is, what is that here? This is 7 for some reason. I don't know why I had 1. It was 7, okay? So both negatives because the middle's negative, but this positive at the end means either this one's going to be both positive or both negative. In this case, because the middle's negative, they're both negative. Multiples of 7 that add to give you 8, 7 and 1. Okay, and they're both equal to 0. Now this is called the zero product property, where you have w minus 7 equals 0 and w minus 1 equals 0. Okay, so your two solutions are 7, and you add 1 to both sides over here, you get and positive 1. So your solutions are 7 and positive 1, or in a sense, put a comma in it. Got it? Okay, w equals 7 and negative 1 and positive 1. All right, let's go ahead to the one right next to it. Same situation. You are going to square both sides. Okay. So this becomes 10x minus 9, and this becomes x squared. Again, when you have the x squared value, you want to get it equal to 0. So I'm going to subtract 10x, add 9 to both sides, because I want this to be equal to 0. So it's going to be x squared minus 10x plus 9. Okay, same or different? Same. Last number is positive. That means it's going to be x minus, x minus. Same, meaning that these are going to be the same signs, both positive or both negative. Middle number, the middle number shows you what sign that's going to be. If this was positive, they both be positive. Since it's negative, they're both negative. Multiples of 9 that add to give you 10, 9 and 1. Okay. So you have x, sorry, can you see that? 9 and 1. X minus 9 equals 0. X minus 1 equals 0. Add 9 to both sides. X equals 9 and add 1. X equals 1. So you have x is going to be equal to 9 and 1. Okay. All right. So that one, again, it's not simple. This is a very complex tool. But again, as long as you're doing your work and practicing, you will get this, okay? So now that you see the square root here, if you see the square root here, on one side again, you're going to do the same thing. You're squaring it, okay? When you square it, it just square root, it goes away. But unfortunately on this side, it's not going to be as pretty, but we're going to have to square it in that way because we have a binomial. So we're going to square that binomial. V times V is V squared. V times negative 4, negative 4V. Negative 4 times V, negative 4V. Negative 4 times negative 4 is positive 16. This side kind of looks the same. We don't do really anything with that, okay? So let's combine like terms in the middle. This becomes b squared minus 8b plus 16 equals 43 minus 2b. I just brought this down again. Okay? Now, again, when you have a squared value, like I said, anytime you have a squared value, you want it to make it equal to 0. So I'm going to subtract 43, add 2b here, subtract 43. They have to be with their like terms. So this is going to be b squared minus 6b, and then we have positive 16 minus 43. Put that in my calculator. I got negative 27. Okay. Now I'm looking at the very last number, same or different. It's actually going to be negative. If the last number is negative, that means there's going to be one positive, one negative. Okay. The middle number determines the bigger value. Okay. So what are your multiples of 27? That's subtract to give you 6. 9 and 3, bigger numbers negative because this one is negative. So 9, 3, okay? Because 9 minus 3, negative 9 and positive 3 is negative 6, just like you get there. So this becomes b plus 3 equals 0, b minus 9 equals 0, subtract 3. b here is negative 3, also add 9, b is also 9, positive 9. So b is negative 3 and positive 9 there. Okay. Okay. So fortunately, unfortunately, that is not even the hardest problem. These problems here, you may not see these on the test. You may see these on the test. If you do see them on the test, there's only going to be one. This takes a while to solve. More than likely, you may not, but I have to show you just in case you do. We're just going to do this one. Again, you can do that one on your own, and you definitely can look at the key. But this particular one, we're just going to do this one, and I'm going to do it on a separate sheet of paper because it takes up a lot of space, okay? So let's write that down. It's going to be the square root of 3x plus 13 minus the square root of x plus 4, and it's equal to 1, okay? All right, so we're going to solve this. First and foremost, we're trying to get the square roots on two separate sides of the equation. So I'm going to add the square root of x plus 4 here. Okay, so I added that on both sides. This becomes the square root of 3x plus 13 equals, now I have, let me make sure that's a minus. Yes, that is minus. So now I have 1 plus the square root of x plus 4. There, okay? And this side is what makes this problem kind of difficult because of that extra piece there, okay? But let's square it because, of course, we're going to try to square it because we're trying to get rid of the square root. So when we do square that side, of course, that's the pretty side, where if you have the square root of a square, you know it just becomes 3x plus 13. But this side is the one where you're going to have to square this situation, okay? And of course, there's other ways to do this, other ways to handle it. This is the way I would do it. The easiest way in my mind. I'm going to do my best to try to give you the easiest explanation. This is just what I would do. So we have 3x plus 13 equals 1 times 1, which becomes 1. 1 times this situation is 1 times square root of x plus 4 is plus the square root of x plus 4. And then square root of x plus 4 times 1 is positive square root of x plus 4. And then this is where you make it confused, but 2 square roots. Remember, if they're equal to each other, and you multiply them, it's just whatever's inside, outside the square root. That's why I just made it x plus 4, no square root. Okay? So multiplying these two of the same just became x plus 4 on the outside. Now combine like terms in the middle. 3x plus 13 equals You can combine that's 1 and the 4 here. That becomes 5 plus x, square root of x plus 4. Remember, there's an understood 1 out here and understood 1. That becomes 2 square root of x plus 4. 1 plus 1 became 2. They're like terms, so you have to kind of put them together. 2 square root of x plus 4 plus x, okay? Because this 4 and that 1 became 5. Now again, I'm going to try to get the square root by itself. So I'm going to subtract away x and 5. Subtract x, subtract 5. That goes away, that goes away. This now becomes 2x, 13, 12, 11, 10, 9, 8, positive 8. And it's going to be equal to 2 times the square root of x plus 4. Okay, so I brought that down. Divide away 2, but when you divide on this side, you have to separate them. Okay, and I usually would do something like that. Make sure everything gets a division, divide by 2. So this one divide by 2, that divide by 2. If there was something else, I would divide it by 2. So 2's cancel out there, cancel out here. This now becomes x plus 8 divided by 2 is 4 equals the square root of x plus 4. Okay, and we aren't done. We are not done. All right, so now we're going to square this, because we have to get rid of the square root. When you square root, you know that it just becomes x plus 4. Finally, got rid of that. But now we're on this side, and we have to square it. Okay, x times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. Okay, so now combine like terms. X squared plus 4x plus 4x is 8x. Plus 16 equals x plus 4. And when you have an x squared value, you have to get it all equal to 0. I know, I warned you. Okay, so now these two cancel out. That becomes 0 equals 16 minus 4 is 12. 8 minus 1x is 7x. And the x squared just comes down. Woo, okay. Now we are same, because we are going to factor same, because the last number is positive, x plus, multiples of 12 that add to give you 7, 4, and 3. So now you have x plus 4 equals 0, and x plus 3 equals 0. Subtract 4 from both sides here. X is equal to negative 4. Subtract 3 from both sides here. X is equal to negative 3. Finally we made it. Okay, these are our two answers. X is going to be equal to negative 4 and x is equal to negative 3 after all of that. So you see why I kind of got to piece of line paper. Okay, so these two, again, you may or may not see them on your test. We did this one, or your Alex, but please make sure you understand how to do that. Okay, all right. Let's go here. Solve the following equation for H. Okay. We're trying to get H by itself on one side. So in order to get rid of this, we first have to get rid of the square root to get H out of there. Okay. So square root squared, we know that goes away and it just comes in H. 3 squared is 9. And now divide by M. There you go. H is going to be equal to 9 over M. This is your answer. How do you know? H is by itself, and that's what it wanted. It wanted H by itself. Okay. All right. So next page. I feel like you guys can do that one. We just did one just like that. Kind of follow the same philosophy. Okay. All right. So we now for this particular one, let's read it. Suppose that an object is dropped from a height of h meters and hits the ground with a velocity of v meters per second. Then v equals the square root of 19.6h. If an object is dropped from the height of 48.7 meters with the velocity, with what velocity does it hit the ground? Round your answers to the nearest tenth. So they give you v equals the square root of 19.6h. And they also said this is the height that they want to know, okay? So they know h, you do not know what the velocity is. So v equals the square root of 19.6, and we said the height is 48.7. All you're doing in your calculator is just putting that straight in, okay? So all you have to do is really read. So the square root of 19.6 and times 48.7. That would be what you're looking at. Enter, and you're rounding to the nearest tenth. So tenth is one place after. 9 makes that go up to 9. Instead of 8, that's going to be 9. So your answer will be 30.9 for the velocity. Okay. Seemed a little harder than it was, but that wasn't too bad. Okay. All right, we can use the formula R equals the square root of S over 12.6 to relate to a ball surface area, S in square inches, to the radius R in inches. Suppose a ball has a surface area of 277.2 square inches. What is the radius? So again, R is equal to the square root of S over 12.6. Here it says we know the surface area is 277.2. So, and we don't know what the radius is. So 277.2 over 12.6. So in that case, we're just going to put it in our calculator. The square root 277.2 divided by 12.6, and I'm not going to be using no backwards L for this particular one because I want my answer as decimal, okay? And it says round to the nearest tenth, and the tenth is here. So 9 is 5 or higher, that will make that 7. So it'll be R equals 4.7, because they want us to round to the nearest tenth, okay? Good, and your radius is in inches, so 4.7 inches for that one. Okay, now let's go to the back. Let's do this one. So let's just start here, actually. All right, so we can use the formula, same formula we just had, radius over S, the square root of S over 12.6 to relate to the ball surface area, okay? So, to the radius in inches. Suppose a ball has a radius of 10.49 inches. What is the surface area? Carry your intermediate computations to at least 4 decimal places and round the answer to the nearest tenth. And we'll talk about that in a minute. Okay. So let's see what happens there. Okay, first and foremost, you have the formula R equals the square root of S over 12.6. They actually give you now the radius of 10.49, and we need to know how to find the surface area. Okay, so we have all of that information. We don't know S. So first and foremost, if we're trying to get S, we know we have to square that. Okay, we're going to have to square those because the square root of a square cancels out. So this becomes S over 12.6. And what is 10.49 squared? So let's look at that. 0.49, and it's squared like that. I just hit the squared button, that X squared button right there. And when I did that, I get, wow. And this is where you're going to round 4 decimal places. So 1, 2, 3, 4. Okay, we don't really have to round. It's already 4. So this particular one, that's where it says right here, your intermediate computations. So this one right here, you round 4 and it already has 4. It's going to be 110.0401. Okay. And then to get S by itself, all we have to do is multiply by 12.6. Okay. So we'll take that number and multiply it by 12.6 to get our answer. And it looks like they want us to round this to the 10th. That's 0, so that stays 5. This will be 1. So S will be equal to 1386.5. Okay, and this is surface area and surface areas in square inches. 1,386.5 square inches is your answer for that one. Okay, and that's how you solve it. All right, so let's look at, sorry about that. Okay, grab that. All right, let's look at the next one. Suppose a wave forms in shallow water, then the depth d of the water in meters and the velocity v of the wave in meters per second are related by the equation v equals the square root of 9.8d. If a wave formed in shallow water has a velocity of 5.2 meters per second, what is the water's depth? So this is the equation, 9.8d, and it has the same situation, carry the intermediate 4 decimal places, and you're rounding to the nearest 10. They're giving us the velocity as 5.2, okay? The velocity is 5.2, so 5.2 for velocity. We don't know what the depth is at that velocity, okay? So what we're going to do is square this. We need to get that out of the square root, and we know squaring a square root becomes just 9.8d. But then we have to put in our calculator, 5.2 squared equals 27.04. So 27.04, and then you're going to divide by 9.8 to get what d is. D by itself, 27.04 divided by 9.8. And that will give you, and you're rounding to the nearest 10th, which is here. 5 becomes 8, 2.8 is your, 2.8 is your answer there, okay? And it says if it's distance, or what is it? Depth, I'm sorry. Your depth is in meters, so 2.8 meters is your answer there, okay? 2.8 meters. All right, so at the bottom of that page, it wants you to solve for the variable. If there is more than one solution, separate them in commas. If there's no solution, put no solution. Okay, let's see. This particular one with the star is the cube root of v, and we're trying to get v by itself. We're going to solve for it. How do we solve for it? Cube it. Cube root, take the cube, just like with the squared. That cancels each other out. This becomes v equals 4 cubed. 4 raised to the 3rd power is 64. Okay, so that's how you get that. Let's look at this one. Same concept, but just understand if it's a cube root, it can equal a negative. Okay, if it's a cube root, it is possible to equal a negative here. If it's a 4th root, it cannot equal a negative. If it's an even root, can't equal negative. This one's no solution. This one has a solution. Let's cube it. Okay, if it has an odd root, it can equal a negative. So we're going to cube negative 3 raised to the 3rd power is negative 27. Okay, cube root, cubing it, cancels it out. This just becomes 7w plus 8. And then we solve this just like we do any other equation, that becomes negative 35, negative 27, negative 8, negative 35 divided by 7. W equals negative 35 divided by 7 is negative 5. Okay, so that is what happens there. This one kind of looks like when we have the square roots on both sides. We do the same thing we do with the square roots. It's do the basically take the fourth root on both sides, and it basically just cancels out the roots. 4x minus 13 equals 2x minus 3. Okay, so now we solve this just like a regular equation. Subtract 2x from both sides, add 13. This becomes 2x equals negative 3 plus 13 is 10. Divide by 2. X equals 10 divided by 2 is 5. Okay, so that is your answer there. Good. So that's that one. Couple more pages. I know this is a long situation, but we got to do what we got to do, right? All right, so here, solve u cubed equals negative 12. Where u is a real number, simplify your answer as much as possible. Can that situation equal a negative? Yes, that is definitely possible. Anytime you have that odd number, it can equal to a negative number. So what you're going to do with u cubed, because we want to try to get u by itself, is take the cube root. And you have to take the cube root of both sides. Okay. Take the cube root of both sides. So this now becomes u equals, let me try to break that down. The cube root of what? Negative 12. 12 is going to be 4 times 3. And 4 times 3 is 2 times 2. Okay. So it doesn't look like there's any 3's in there. Your answer here is just going to be the cube root of negative 12. Okay? I want to say that a negative could come out in the front. That's what I want to say. Hold on really quickly. All right. So yes, the negative on the inside here is actually going to come outside when you have it in for the cube root. We can't break 12 down. There's nothing we can do with that. So that negative on the outside is going to come, the negative on the inside will come outside. That's basically all you can do here. And this is the cube root of 12. And we showed it over here. There's no 3's. It's 3 of anything. Remember, the same number has to be in there 3 times in order for it to come out once, and it doesn't happen. So it's just going to have that negative just come on outside. Okay? All right, so we solved this kind of like we did with the square. Okay? We would take y plus 10 cubed and kind of get it so that it's by itself. I'm going to add 24 to both sides here, and it'll be equals to 24. I took this negative 24 and put it on that both sides, okay, and it canceled out here, and then it got over here to be 24. Now I'm going to take the cube root. So that the cube root and the cube root and raising something to the cube cancel each other out. This becomes y plus 10 equals, and then we have the cube root of 24, okay? Cube root of 24. Again, that will break down into, let's see, 24 is 6 times 4, 4 is 2 times 2, and 6 is 3 times 2. This is 24, okay? And of course, we have 3 2's right there. Okay, we do have 3 2's. They come out one time, so the 2 came out, and then the cube root of 3 stayed in. And then if I subtracted 10 from both sides, it becomes y equals negative 10, and then plus 2 cube root of 3. There's nothing you can do with that. That is just going to be your answer. It's ugly, but that's just what it's going to be. Okay, It just wants to make sure you write your answer in a simple radical form. And this is, unfortunately, it looks a mess, but that is what it's going to be, okay? Once you get your answer there. All right, next. Solve for the variable where the variable is a real number. If there are more than one solution, separate them with commas. If there is no solution, say no solution. In this situation, believe it or not, I would change this into radical form so that we can solve it. So if we have this, you know, this is your root. So this is the fourth root of x to the 1 equals -4, okay? If you have a even root, it cannot equal a negative number. Even root cannot equal a negative number. This one's no solution. Okay. Again, I would now change this one, the same thing, and I would make this the cube root of v to the 1 equals 2. Okay. And then I cube both sides. And you know, if you have a cube root and a cube, they cancel each other out. This becomes v equals 8. 2 times 2 is 4, times 2 is 8. So that is your answer there for that. And no solution for this one because you cannot have a even root equal a negative number. Here we are simplifying, we're using actual i's now, okay? If you have, this I represents an imaginary number. Okay, I is an imaginary number. An imaginary number represents a negative under a square root. Negative under a square root, you know you're going to have an imaginary number. So like for this particular case, I'd have an I because I have a negative under the square root. I'm just going to bring that I out. Why did I make that a J? I meant to make it an I, okay? So now what's the square root of 25? 5. Your answer is going to be 5, and I'm going to put the I with it, okay? So I just brought the I out first, and then I took the square root. So the same thing here. Do you see that there's a negative already out? I'm leaving it. And if there's a negative under the square root, I'm going to make it I. I'll leave the number under there, okay? When I take the I out, I make that number positive. So the I represents that negative that's under there. So now square root of 36, this now becomes negative. Square root of 36 is 6, I. Okay, and I usually put the I after the number. Okay, let me bring that I out, make that positive 80. And now for this one, it's not a perfect square, so I'm going to have to kind of break it down. Let's break 80 down. 80 is 4 times 2, 20. Okay, and 4 is 2 times 2. But we know that 4 is a square root, so I'll just leave the 4. You know, that's going to be the square root of 4 is 2. 2 is going to come out. Square root of 4 and 5, square root of 5. This becomes 2. So 2 2's came outside. The square root of 5 had to stay inside. 2 2's came out. That's 2 times 2 is 4. So this becomes now 4i on the outside. And then that square root of 5 has to stay inside. So that is how that would look with the imaginary number. Okay. If you had 2 negative numbers here, we're leave no negative numbers under radicals, no radicals in the denominators, and we're on the imaginary number situation. 2 negatives, if you multiply negative 15, okay, negative 15 times negative 5, you get positive 75. So this, when you put them together, that becomes positive 75. That is not a negative number. So this is the square root of 25 times the square root of 3. We know the square root of 25 is 5. So this becomes 5 square root of 3 is your answer here for this particular one. Okay, so it doesn't become as nasty as you would think. In this case, I just divide negative 60 by 10. So negative 60 divided by 10 becomes negative 6. Okay, so this here, once you have both of them have square roots, I can just divide them. This became negative 6. So I can't simplify that negative 6, but I can take the I and make it, because it has a negative under the square root, I'm going to bring the I out. The square root of 6, there's nothing I can do there. That is just your answer. You can't simplify that. I squared root of 6 is your answer. Okay, if we had the same situation here, negative 81 divided by 3 became negative 27. So this is the square root of negative 27. I simplified these two. And then I can take the I out, and we know that this is the square root of 9 times the square root of 3, and 9 is 3. So this now becomes 3I, because there's an I sitting out here, times the square root of 3. Okay, so the only real difference is that I, because it had a negative under the square root. That's the only time you have an I. And in this case, we didn't have an I because these two became positive when they multiplied together, and then now no I is needed. Okay, but we still use the same rules. The same rules apply. All right, so what you need to know here is that I squared is equal to negative 1. That's something that's important in this situation, okay? When you have an I squared, your answer becomes negative 1. And we need that when we're adding and multiplying, and if we ever see an I squared, okay? You kind of got to know that. So, oh, I dropped my pencil, sorry. Okay, so for this situation right here, you're combining like terms. This would be like I is a variable. We're not, you handle it just like you handle a variable, like if this was A or something. So this is a plus actually. On the paper it looks like a negative, but it's a plus. So we have negative 5I plus 1 minus 6I. You're combining like terms. This becomes 1. I'll just bring the 1 to the front, plus negative 5I, negative 6I, actually become negative 11I. Okay, 1 minus 11I, and this is in standard form where the I is last, constant is first. 1 minus 11I. Okay, let's go here. With this one, you distribute the negative first. So you leave this alone. Negative 1 plus 3I plus 5 minus I. So when you distribute that negative, all it does is change the signs, and now we can combine like terms. Negative 1 plus 5 is 4. Positive 3I minus I becomes plus 2I. Okay, so that's how you got that. In standard form, 4 plus 2I. All right, let's look at this one. Negative 2 times negative 5 becomes positive 10. I'm just going to FOIL here. Negative 2 times positive 5I becomes negative 10I. 2I plus, 2I times negative 5 becomes negative 10I again. And then 2I times 5I. So with this one, you multiply the numbers, 2 times 5, and you got 10. But remember what I said, I times I, which is I squared, becomes negative 1. So I times I became negative 1. So now it is 10, and then we're going to combine like terms, negative 20I. And this now becomes 10 times negative 1, which is negative 10. And if I combine these two, they cancel each other out. My answer is negative 20I there. Okay, and it's that I times I. Let's go ahead and try this one. 1 times 5 is 5. 1 times negative 3I is negative 3I. Negative 6I times 5 is negative 30I. And this is where the issue comes in. Negative 6I times negative 3I. So negative 6 and negative 3 becomes positive 18. And then I times I is I squared, and I squared is negative 1. Okay, and that can trip you up if you don't do that extra step. All right, so now it becomes 5, and this is negative 33I minus 18. And then we have 5 minus 18, that becomes what? 13, negative 13. Negative 13 minus 33I is your answer there. Okay, perfect. All right, so we are right here at the end. We have a couple more, and we have one more page at the beginning, which shouldn't give you too much trouble. All right, so multiply. Assume all variables represent positive numbers. We're going to go ahead and do this. This is not an easy problem. These give people so many headaches, but I think that we can handle it, and I will show you the best that I can do. Usually what I do here, again, there's multiple ways to do this. What I do is cross simplify when you're multiplying. When you're multiplying, I cross simplify, okay? What do I mean? Meaning that I can simplify anything that's on the top and bottom. So anything up here by anything down here, no matter where it is, okay? So I can simplify 125 and 5 by dividing both of them by 5. That becomes 1, and that becomes 125 divided by 5, I think, right? No. 125 divided by 5, I'm sorry, it becomes 25. What am I doing? All right, Slate. All right, so 25 there. Then I'm going to cross those two out. Looks like there is 5 X's up here and 3 down here. That means there's like 2 X's left there. Okay, and remember I'm subtracting because exponents you subtract when you divide. So 15 minus 9. 15 minus 9 became 6. This y to the 6 is left over here. Good. So basically what's happening, what's left over, all the bottoms canceled out. And here it became 25 x squared y to the 6th power, all on the top. Okay, because I cross simplified. So make sure you're doing that. Go ahead and try that one. Check out the key to get the answer, but go ahead and try that one. I bet you could do it. Crossing out the bottoms and the tops and subtracting the exponents. You have to, okay? All right, so let's go here to evaluate, state not a real number is applicable. Let's try this. Remember, this is a square root even, so this number here has to be positive. You should see that that is going to be a positive number because raising it to an even power. But do you understand that this is basically like -3, -3, -3, and -3? There are 4 -3s under here. That means when you pull this out and pull that out, what comes out? A -3 and then another -3. So 9. Okay, -3 times -3 is positive 9. That comes out of there. Okay. So let's see if we can put that in our calculator. Let's see how that works. So if I said the square root of -3, raised to, well, I guess I'm going to have to put another parentheses in there because that -3 is in parentheses. And it has to be raised to the 4th power. Close that off. So that this parenthesis belongs to the -3, the outside belongs to the whole thing. Push enter, look, it gave me 9. So that you were able to put that in your calculator. Let's try the next one. Let's say square root of parentheses -10 squared, parentheses squared, and then close that all the way off. Push enter, we get 10. Okay, so it is kind of working there. Let's see if this one would work for you. Yeah, that one's going to work because 10 squared is 100. So basically the negative is on the outside. 10 squared is 100. Square root of 100 is 10. So this just becomes -10. Okay? Because again, 10 squared is 100. The negative is just standing on the outside. So whatever number comes out just becomes negative. Same thing here. Okay? So this becomes negative. Whatever comes outside, which is, because this is basically 4 times. 1, 2, 3, 4. 1, 2. Okay, 2 4s came out. 4 times 4 is 16. So that becomes -16. Okay. So it isn't that hard. You don't have to really break anything down. You could have easily just put that in the calculator and got an answer for that. All right, so I felt like that one kind of like the middle was kind of crazy, but the end got pretty cool. It wasn't as bad, okay? So now let's go, this is the last page, and this is the distance formula. This is really, really leading you into unit 9, which is your last unit, which goes really deep into graphing and all of that. Graphing and, you know, what are you doing in there? I know you're doing circumference and I can't really remember. I guess we'll get into it soon. But you're definitely doing slope and you're doing parabolas and all kinds of stuff like that. So this kind of leads you into unit 9. So the distance formula is here. The square root of x2 minus x1 squared plus y2 minus y1 squared. The only issue here is basically you're trying to find the distance between these 2 points. You have to know how to label. Once you know how to label, you got it, okay? So negative 9, 2 is a point, and the other point is negative 1, 5. All you have to do is know how to label. Each point has an x and a y. x1, y1, x2, y2, xy, xy. Once you learn how to label, you're good. Now all you're doing is substituting. So y2 is negative 1. So here for our distance formula, as we said, x2 minus x1 squared plus y2 minus y1 squared. Put x2, this is x2, negative 1. So now you're just going to substitute. x2 is negative 1 minus x1 is negative 9 squared plus y2 is 5 minus y1 is 2 squared. And I put that all under my calculator, in my calculator. Now, how you would do that really is please make sure you double, oh, that's not it. Double, I'd always double for this particular, for distance, I'd always double parentheses. And then you're going to put this in, this particular one in. So negative 1 minus negative 9, you can put that like that. Fine. Squared. If you didn't put this little double parentheses and all that stuff, if you put it like this, it'll get it, it'll understand it. Okay, if you put minus negative, in real life, I don't like that. I'll just make it plus, but you can do that and it'll still understand it. Plus parentheses 5 minus 2, and then also square that, and then don't forget that last parentheses after, because we put a double one in the front. Okay? Give an exact answer, not approximation. Blah, 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 blah. What does that mean? It doesn't want a decimal, okay? So let's do it by hand. As you see, that the answer came out to be a little decimal. We don't like that. It doesn't like that. So we're going to do basically negative 1 plus 9 became 9, 8. 8 squared. 8 squared plus, and this is 5, 4, 3 squared. Okay, and 8 squared is what? 64 plus 9, 73. D equals the square root of 73. Okay, and you can leave it like that. Does not want a nasty decimal. So wasn't that bad if we did it by hand. Same thing here. Negative 9, 0. Negative 3, negative 8. Do not forget, each point has an x and a y. x1, y1, x2, y2. You will just be surprised at how many people miss that. Just because they mess it up. X, y, x, y. Always x, y, x, y. Okay, each point has an x and a y. So now you're going to put it in the formula. D equals the square root of x2, which is what? Negative 3 minus x1, negative 9, I'm going to say plus 9. Minus negative became plus, and then squared. Plus y2, which is negative 8, minus 0, which y1 is 0, squared. And let's kind of do it by hand. 9, 8, 7, 6, 6 squared, plus negative 8 minus 0 is negative 8. Negative 8 squared. 36 plus 8 squared, or negative 8 squared, is what? 64. Okay. So 36 plus 64 is 100. And the square root of 100 is 10. So our distance. Okay. That's our answer there. And we got the answer there. Okay. Finally, we are done with Unit 8. Look forward to our Unit 8 review.